Okay, so here's a graph. I would use my pencil so I don't. So you can erase it if you want to. Okay. So here's a velocity function, but we don't have the function. This is the velocity graph if you want. And we're asked, what is the distance covered by the car while braking? So from this velocity, whatever that is, it appears to be 50, to velocity 0. And of course, it's clear that it's between 0 and 6. So if I want to determine the distance, right, I will determine the integral from v of t dt. And that will give us the function, right? Now, I don't have the function. If I want to determine just the distance covered by the car while braking from 50 miles an hour to 0, then I will say the integral from 0 to 6, right, from v of t dt. And this will give us the exact distance. But the function is not given to us. We only have its graph. So from this graph, how will I determine the distance covered? Well, the integral from the velocity is the area of the graph. So if I manage to estimate this area, I will tell you with a good approximation of the distance covered by the car. It could be dry pavement, wet pavement, I don't know. This is what is given to us in 6 seconds from 50 miles an hour to 0. Okay? So all I can do is just estimate this. So, for example, this rectangle appears to be 20 by 2. So this piece is 20 by 2. Let me use multiplication so it's not. I'm going to erase this if you want, Greg, I'm sorry. So then the next one, full one, right? I'm going to say it's 1 by 15 plus 1 times 15 plus. I'm going to say approximately here is also, what is it, 1 by 20. And then now I have to estimate this piece, this piece, this piece, and this one. So I was able to estimate what were full rectangles, right? But now here, I would probably say that this piece is kind of this piece, so I can say that this is a full 1 by 20, right? So this is 20, this is, no, what is this? 20 and 35, right? So by 10. Did I put that correctly in there? Was it 1 by 10, right? Not by 20. Is it? So I'm going to do this again. So this was 20 by 2. That's correct. This is 1 by 15. That's correct. And now this piece, it's between 20 and 35. So 20, 30, 40. Sorry. So this is 20. Okay, that's correct too. Okay, so I'm going to say that this piece is kind of this piece. So I'm going to have another piece like 1 by 20. It's all estimate. So let's say I'm done with that. And now I just need to estimate this piece. Okay, I'm going to say it's possibly this 2 by 15, another 2 by 15. And now I'm left with this piece. I don't know, maybe half, or maybe 1/3 of 1 by, what is this, 10? No, that's not good. So what am I doing? So this is by 7.5. Okay, so plus 1 times 7.5. So this is a rough estimate. So when I add this up, I perform all these calculations, I will get, let me calculate, so let's see what we get. So 40 plus 15 plus 20 plus 20 again plus 30 plus 7.5. You have to redo this, make sure. I got about 133, approximately 133 feet. Just wanted you to have an idea of how to perform these operations. So for the car to brake, right, in 6 seconds, it will approximately be maybe 130, 132.5 feet. And that's the area. Because when we integrate the velocity, we get this area, which represents the distance. If we had the velocity function, we would have integrated and we would have gotten the exact distance. You want me to erase all this?
No. Thank you.
Thank you. Okay, that was one thing I wanted to cover. And that was a perfect example. Then we have a couple of questions. The integral from -2 to 0, from 1/5 x to the third plus 1/4 x squared minus x dx. Was this a wrong answer, or did they say something, or was it a problem with it? Or?
I just looked at it.
Okay, very good. So let's do it. No problem. Okay, so let's find the antiderivative. 1/5 is 1/5. Of course, x to the fourth over 4 plus 1/4 x cubed over 3 minus x squared over 2. Everything from -2 to 0. Is this okay, everyone? So I copied 1/5. I increased the power and divided by that number, the result. And then I copied 1/4. I increase the power and I divide by the corresponding number, and then x squared over 2. Is this okay so far? Yes? Okay, so then now we have to plug in 0, but it's all 0. But what you have to remember is to put the minus in front. And now I will plug in -2. I will have 120, 1 over 20, and then -2 to the fourth power, that is 16, plus 1 over 12, times -2 to the third power, which is -8, and minus 1/2 times 4. Is this okay?
Are you making that 1 over 20 x to the fourth when you plug in these numbers, or is it? Or you just plug in?
Oh, you wanted to rearrange it and simplify it a little bit? You could.
Right. So the simplified is what you're plugging in these numbers.
Yes, because I multiply these two, and I always prefer the constant outside.
Okay.
Because it's better and easier to handle it if you just leave it outside. But I don't have the same constant in all of them, so that's why each product looks differently.
Okay.
Was that the question?
Yeah. Yeah. I got you.
Did I answer it? Okay. So now I'll simplify by 4, and I get this. Now I'll simplify also by 4, and I get this, and then -2. I can distribute, and this just the first one is negative. And I still have to find the least common denominator. And remember, this is the least common denominator. We have to multiply the tops by the appropriate numbers. So the first one gets a 3, the next one gets a 5, and the last one gets a 15. We know why, right? Okay, so this would be -12, and then +10, and then +30. So this is -2, 30 minus 2 is 28, so I have 28 divided by 15. And I cannot simplify it any further. Is this okay?
Mm-hmm.
Any questions? Any questions?
Can you explain what
Yes.
this is going to be used for?
Yes, exactly. Excellent. Can I get that graph again?
Yes.
For this. Integrating any function will give us the area under.
That's what.
Yes. Also, if I integrate this function, just the function itself, not the definite integral, the indefinite integral, I will determine the function whose derivative is the velocity. And if I want to determine the definite integral, which will always give us a number, I am really calculating the distance covered by the car in case this is the function. It's not, of course. But in case this is the function, the velocity, when I integrate, I get 28 over 15. This will be the area under the graph, which in this case will signify the distance covered by the car while braking from blah, blah to 0. That's where we use this. And the nice applications, however, I want to show you, since you asked, it's a very good question. Here it is. But these are in chapter 6, this is in calc 2. And I beg for a calc 2, and maybe there is a chance, I'm not sure, we'll see. Okay, so what you're going to see in calc 2 is this. You're going to have this piece, this area, and you are going to rotate it around any axis. It doesn't have to be the x-axis, it can be this axis, and you rotate it, and it's an open in the middle. So you're going to get these figures, and you're going to be able to find the volume of this. It's not a cone, because as you see, the function is the square of x, but with the use of an integral, you will be able to determine the volume of this solid. So assume that this is, I don't want to show something, but you can determine any volume like that. So for example, you have this area, and you are rotating it, and you get a cylinder. You'll be able to determine the volume of the cylinder with the integration. So these are the applications of integration. So that's the next step. Even something like this. Not just areas, but as I showed here, volumes as well. But without integration, you will not be able to. So in Calc 1, at the end of Calc 1, with Chapter 5, we only show techniques, basic techniques of integration. In Chapter 6 and beyond, we look at other more sophisticated techniques of integration, like integration by parts, integration with trig substitutions, and so on and so forth, to enable us to determine those volumes and areas. So those are more sophisticated than what we're just determining here, the area under the graph. Very good question. Keep me on track so I don't forget to explain why. This is a very good question. Okay, Greg, is this okay?
Yeah.
Every step?
Yes.
Other questions here on this one? Other questions? Very good. Now we are given f prime of t, which is 16 over 1 plus t squared. We are told that f of 1 is 0, and we're asked to find f. So we want to determine function f given the information we have. Since this comes from 5.1, maybe we should not use integration. So we want to determine f of x, and we're asking ourselves, which function prime is 16 multiplied by 1 plus t squared? Oh, since it's t, allow me to change it. Sorry about that. So we're asked to find f of t. So exactly. So this will be 16 arctangent t plus a constant c. So this is the function. However, we have a condition that says f of 1 equals 0, and we're going to plug it in and determine the constant. Okay, so we know that f of 1 is 0, which means 16 arctangent 1 plus the constant c equals 0. So now the problem reduces to finding arctangent 1, which means which angle has tangent 1. And there is only one nice angle that has tangent 1. Pi over 4, thank you. So this is 16 pi over 4 plus a constant, but the plus c equals 0. I'll simplify, so I get that c equals negative 4 pi. That's all I need. So now I can go back and rewrite the function with negative 4 pi. So f of t equals arc tangent t, of course I forgot the 16 in front, my apologies, minus 4 pi. Okay, next question we have is the integral from 1 to 2, v to the 4th plus 4v to the 6th divided by v to the 3rd dv. Now I know that my students started studying chapter 5 because they finally have questions in chapter 5. Good, I'm happy. Okay, so we don't know how to integrate a ratio like this, but I know what to do with it. And always keep in mind, factor simplify, these should always be in the back of your mind. So of course, because the denominator is just one term, I can separate the fraction and simplify it. So then the integral becomes from 1 to 2, v to the 4th over v to the 3rd is v, plus 4, v to the 6th over v to the 3rd is v to the 3rd. And now, obviously, from this point on, it's not a big deal. So what happens next? I have to find the antiderivative, and after that, I just plug in the top, the upper limit, minus when I plug in the lower limit. So this is v squared over 2 plus v to the 4th over 4, everything from 1 to 2. I will simplify just these 4's, and then I plug in 2. So 4 divided by 2 will be 2, plus 2 to the 4th is 16. Don't forget minus. I plug in 1, 1/2, and minus again, 1. It is sometimes safer to put parentheses before you distribute negative 1 so you don't forget. You must distribute negative 1 to both. So 4 divided by 2, and then 16, and then minus when you plug in 1. Since both terms are positive, they will become negative. Is this okay so far before we finish it up? Yes? Okay. So this is 18 minus 1 is 17. 17 minus 1/2 is 34 minus 1, 33 divided by 2. And we have one more to look at. Any questions on 33 divided by 2? Is this okay?
Yes.
Okay, so let's take a look at a bacterial population is 5,000 at time t equals 0. When I see this, I immediately write this, because that's what it means. We are given a point. Okay. And its rate of growth is this. So there is a function, its rate of growth. So it's a derivative, which is 1,000 times 3 to t. One more time. So let's read this again. Always try to literally dissect piece by piece whenever you have a word problem, right? Just make sure we understand. So bacterial population is 5,000 at time t. Obviously, I'm given a point 0, 5,000. Then it says its rate of growth. When I see rate of growth, obviously it's a function, but it's a derivative. is the rate of change I drive at 50 miles an hour. It's the rate of change, right? So the rate of growth is this. So that's a derivative. Bacteria per hour after T hours. Fine. What is the population after 1 hour? So this is what I'm really asked to find. In other words, 1 comma f of 1. This is the question. But how can I determine f of 1 if I don't have f, right? So I am telling you find f of 1, and you should say, give me the function, and I will give you f of 1. But if I don't give you the function, you'll say, I can't. So we have the derivative. We will have to determine the function. It will have a constant in it. We will have to determine the constant given the point, and then at the end of the day, I will be able to give you f of 1. Does it make sense? Any questions? Okay, so let's find the function first. F of t. Which function prime, careful, which function prime is 3 to t? And that brings me to something very important that I forgot. And we did this problem in class together. When we differentiate 6 to the x, we get 6 to the x times natural log 6. We talked about that. Let's talk about it again. So if I differentiate e to x, I should write e to x times natural log e. How come I don't write natural log e? Exactly, because it's 1. So when I differentiate 6 to x, is the same thing. I have to mimic this. 6 to x times natural log 6. However, this time, yes, no?
Is it also times whatever?
If it's a function.
Okay.
Absolutely. If this is a function, yes. 6 to the function from. Sorry. 6 to the function prime is 6 to the function times the function prime times the natural log 6. Yes. So please don't forget that. So now, when I want this has to be in the denominator when I go backwards. So which function prime is 3 to t? You have to say 3 to t over natural log 3 plus a constant c. Remember, definite integrals are not friendly because I can't check. But indefinite, I can always take a moment and say, let me see. Is this true? I have no idea. Let's check. So when I differentiate this, the constant stays in front. I differentiate 3 to t as 3 to t times natural log 3. And when I differentiate the constant, I get 0. Right? So I found the function. I have to plug in the constant that says that f of 0 equals 5,000. So I have 1,000 times 3 to 0 over natural log 3 plus c equals 5,000. And this is how I determine the constant. Okay. How much is 3 to 0? 1. So then c will be 5,000 minus 1,000 over natural log 3. Ugly, but that's what it is. Sorry. So c equals 5,000 minus 1,000 divided by natural log 3. You can simplify it a little bit. I will take out, of course, 1,000, and I have 5 natural log 3 minus 1 over natural log 3. Is there a need to do this? No. It doesn't matter. So now I can put it back in the function anyway. So now I have everything about the function. I know everything about it. So it's 1,000 3 to t over natural log 3, and then plus 1,000 5 natural log 3 minus 1 over natural log 3. And you don't have to do anything to it. Now, they are asking us to determine how many bacteria are there after 1 hour. So I have to plug it in 1 hour. I have to use the calculator because I will never tell you, if you ask me how much money you have in your pocket, I'm not going to say 1,000 times 350 over natural log plus 1,000 times 5 natural log 3 minus 1 over natural log 3. So I have to determine this. So let's determine it. So I'll take out 1,000 and I will have 3 divided by natural log 3 because I'm plugging in 1 plus in parentheses again 5 natural log 3, close the parenthesis for the natural log and minus 1, and close the parenthesis and then divide by natural log of 3, close the parenthesis for the denominator. Let me see what I did. Do I need an extra? Yeah, I do. Yes. Okay, enter. So I got 6,820. So f of 1, 6,820. So careful, let's see. Round your answer to the nearest whole number, which makes sense, right? If I get 65.3 people, I have to say still 65, right? I can. So I'll say 6,820. So 1 comma 6,820. So we started with 5,000, and in an hour, we have 6,820. Very good question. Thank you, I appreciate it. Okay, next, did you have anything else?
No, that's it. Thank you.
Anything? You're really helping, yes.
I just had a question.
Yes.
There was a problem I did, and it was like one we did earlier, but it had 2 functions.
2 values for the function, yes. So we have the acceleration, t squared minus, is it 40?
4t.
40 plus 8, very good. T squared minus 4t plus 8. And we are given that s of 0 and s of something else.
S of 0 equals 0, S of 1 equals
20? Very good. Okay, so, and we are asked to find distance. Good, so we're given the velocity, we have to, we're given the acceleration, we have to go back to the velocity and then to the distance. So can anyone tell us what to write for the velocity?
t cubed over 3.
Very good.
So it's minus 2t squared plus 8x plus 2.
Good. Is this okay?
Sorry.
So t cubed over 3 minus 4 times t squared over 2 plus 18 plus c1. Is this okay? Good. I don't have any information about the velocity, both conditions. So when you go back to reviewing what we covered in class, we had several examples like this one. So you don't get stuck. So we don't have any information about the velocity. We're not given any point. So we have to continue. That's the reason why I used C1. So now we have 1/3. T to the third comes from t to the 4th over 4. This is 2. T squared is coming from t cubed over 3 plus 8t squared over 2 plus c1t plus c2. So let's do this together. So keep the constant outside because it's easier to multiply. So then t cubed, when I differentiate this, I get t cubed. Then I copy -2. When I differentiate this, I get t squared. Then I copy 8. When I differentiate this, I get t. When I differentiate this, I get c1. And when I differentiate this, I get 0. Now I have to clean it up a little bit, and I have 2 conditions. Both of them serve this function. So I will write S of t equals 1 over 12 t to the fourth minus 2/3 t cubed plus 4t squared plus c1t plus c2. And now S of 0 equals 0. You understand all these terms will be 0. Therefore, C2 is 0. Would you agree? Do we agree so far? Yes? I know you're tired. I know it's the end of the semester. Please bear with me. I know. 2 more weeks after this one. Not even that. So then this is 0. And now we have S of 1 equals 20. S of 1 will be 1 over 12 minus 2 over 3 plus 4 plus C1 equals 20. So I plug in 1. So 112 minus 2/3 plus 4 plus C1 equals 20. And from here, I will determine C1. Is this okay, everyone?
You plug in 1, right?
Yeah, because I have S of 1 is 20. So 1, 1, 1, 1 equals 20.
Uh-huh.
Is that okay? Okay, so C1 equals 20 minus 4, which is 16. I move negative 1 over 12 and plus 2/3. Okay. The least common denominator is 12. This one gets a 12, and this one gets a 4. How much is 12 times 16? I'm lazy today. So 72, 192, correct me if I'm wrong, please. Minus 1 plus 8. Is this okay? So this is plus 7. So I got 199 over 12. Please say yay or nay. Is it okay? Okay, so now we have the entire function. S of t. 1 over 12 t to the fourth minus 2/3 t to the third plus 4t squared plus 199 over 12t. Was 199 over 12 okay? So 18 plus 119, that's not divisible by anything. Okay, so I can simplify, so that's it. So this is the only function that fulfills the given conditions. Has a second derivative, the function that we were given initially. S of 0 is 0 and S of 1 is 20. Very good questions. Thank you for doing this. Anything else? I have one thing left over before we start reviewing, but I can start reviewing, I can start doing anything else. So I just want to discuss the total distance. Remember when we talked about the particle going back and forth and in the positive direction, negative direction, the distance covered? Now we can do that with the integral, which we couldn't do in chapter 3. So that's the only thing that I have not presented yet. Any more questions? Anything you have for me?
Is there any way,
Yes?
you can do the problem where we have to flip the integral and bring the negative to the outside?
Yes, of course. I'll let you choose. Anything you want. There are a few examples of that, I think, yes, at the end of the book. Here it is. So we're talking about a function given in the form of an integral. Is that what you meant?
Yes.
Okay, so please choose anything you want from here.
45.
Okay, we want to look at 45. That's the easiest one because it has a constant already. So it's already prepped for differentiation.
Oh, I see, yeah.
This one is not prepped for differentiation. This one is not prepped for differentiation. But this one, every time the constant, any constant, is the lower limit. Here I just have to flip the limits of integration. That is part 1. Meaning I can differentiate both sides, and all I have to do is plug in t, replace t by x to the fourth, and multiply by 4x cubed. Done. But all these, the other ones, the last two here, are not prepped because I don't have a constant here, and I don't have a constant here. I have to break out the integral into two integrals, and then I have to rearrange the first one. But it's up to you, whichever you prefer.
Yeah, can we do 47?
47, 48, which one?
47.
47 it is. Okay. This is page 417. So we have y equals the integral from the square root of x till x from e to t over t dt. You understand that this is a function of x because the limits of integration are in x. That's why we cannot have x here. We have to have any other variable with x. Not x. Okay. So we are asked here is not to calculate anything. We're only asked to differentiate. In other words, use fundamental theorem of calculus part 1 that says when you differentiate an integral, you get a function. When you integrate a derivative, you get a function, meaning the operations are inverses of each other. We integrate a derivative, we get the function. We differentiate an integral, we get the function. That's all it means. But this is not prepped for that. So let me refresh your memory on fundamental theorem of calculus part 1. So this is g of x, an integral from any number to x from f of t dt. This is a function given as an integral, but it's still a function. So now differentiate both sides. Here's what happens. So when we differentiate the left-hand side and we differentiate, the right-hand side, that is the result. And this is what we learned from Fundamental Theorem of Calculus Part 1. Okay? But the function is not ready for this. It has to have a constant here. It can have anything here. Maybe I should write here times x prime. Maybe that's just to refresh your memory. I should multiply here by x prime. This x prime. But how come I don't? Because it's 1. Exactly. Thank you. Good. So now, first thing we need to do is break up the integral. And where do you break it up? It doesn't matter. So you can write the integral from the square root of x to whatever. But it has to be the same whatever to x from e to t over t dt from e to t over t dt. Some students like how some of us say, I want to put 0 in here. Put 0. Others put a. Put a. Others put 5. Put 5. It doesn't matter. So as long as these two are the same, we're applying one of the properties. We're using one of the properties of a definite integral. And after this, I still have one more prep. This has to be reversed. I mean, the limits of integration have to be reversed. So then we know that there is a property of the definite integral. Every time we reverse the limits of integration, the integral becomes negative. Or opposite. From that to the square root of x, e to t over t dt, plus sorry. Good. So now we're ready to find the derivative. Nothing else. We cannot do anything here. We are only asked to find the derivative. So when I differentiate the first integral, only the function is left, but I have to replace t by the square root of x. And since the square root of x prime is not 1, I have to multiply by the square root of x prime. Yes?
So it's negative and that one
Here?
says about, yeah. And that one
Because
says about,
that's one of the properties
right.
of the
So,
integral. I don't have to switch this one because it already has a number as the lower limit. So
gotcha.
this one does not have a number initially as a lower limit, so that's why I have to reverse them.
Yeah, okay, I got you.
I don't reverse the second one because that one is okay.
Okay.
So when we differentiate the first one, we have to write negative e to the square root of x divided by the square root of x times 1 over 2 the square root of x. This is because of this. It's 1 here, that's why we didn't need it, but it's not 1 here. And again, when I differentiate the second one, I get e to the x over x. In this case, I don't need anything because I would have written times x prime, and x prime is 1. And we can further simplify. Look how nice this comes out to be. Thank you for picking that. So then y prime equals negative e to the square root of x over 2x plus e to the x over x. So the only thing we can do, since these are not the same, we could find the least common denominator, which is 2x, negative e to the square root of x plus 2e to the x. That's about it. This step is really redundant. That's fine. The first one is okay. Very good question. Anything else you would like to go back to? Other problems, or we go back to, or we look at, because we haven't talked about the total distance. Displacement and total distance. Did you have anything else right this moment? Yes? Okay, displacement. This is really the last topic. It's just one problem. And total distance. Very, very similar to the particle situation that we looked at. So I'm going to pick a problem. These problems come from section 5.4. Okay. Oh, please stay. Okay, so here we're asked to, we're given the velocity function in meters per second for a particle moving along the line, find the displacement and the distance traveled by the particle during the given time interval, either 59 or 60 you choose. Or we can look at the acceleration function is given, and the initial velocity is given for the particle moving along this line, whatever, a line doesn't matter. The velocity at time t we're asked to find, and then we're asked to find the distance, total distance traveled by the particle within the given time interval. So maybe we should choose one from each, because I also want to talk about the displacement, which is not a question here. Now, obviously, this is a quadratic function. We have a little bit more work than a linear function. Here it doesn't matter. They're both linear. So, okay. So problem 60 on 405. We're given the velocity, which is t squared minus 2t minus 8, and the interval is between 1 and 6. In part A, displacement. And in part B, the total distance. So in other words, in part A, we would like to determine in which direction the particle is moving. In part B, with the total distance, we want to find the total distance, the accumulated distance, regardless of which direction the particle is going, will determine the total distance. Okay. So for displacement, obviously, this is nothing else but s of 6 minus s of 1. Which, of course, is nothing else but the integral from 1 to 6 from v of t dt. The answer will be a number, of course, and we will find out if the number is positive, then the particle is moving in the positive direction, or is negative in the negative direction. So that's not a big deal. Integral from 1 to 6, t squared minus 2t minus 8 dt. And we get t cubed over 3 minus 2t squared over 2 minus 8t from 1 to 6. Now this is the easy part. The more difficult part is to plug in 6, calculate, and subtract when you plug in 1. That's more tedious than writing this. We agree? So I'm going to plug in 6. 6 cubed divided by 3 minus 36 minus 48. Don't forget the minus in front of when you plug in 1. 1/3 minus 1 minus 8. So how much is 6 to the third over 3? 216, 72. 72? Okay, thank you. Minus, what is this? Is this 84? Minus 1/3 and plus 9. Watch out my numbers. Okay, so 81 minus 84, so this is negative 3 minus 1/3. I got negative 10/3. Okay. So obviously it's moving 10/3, 3 and 1/3 in the negative direction. Now, this second part of the problem is more difficult. Total distance. It is still the integral from 1 to 6, but it's from the absolute value of the velocity function. Which is a different story. I don't have the absolute value of the velocity function. I have to determine it. I can't put it away just yet. So the velocity, one more time, is t squared minus 2t minus 8. And of course the interval is 1, 6. Okay, so this is nice, but the absolute value of this will not be nice. Especially because it will give us two different options, number one, and number two is a quadratic function, so that's not easy to work with. So what do we do? What are the options? So what do we have to do first? No. This is just algebra. Only algebra. We're just discussing algebra now. No derivative, no integral, nothing. So what is the formal definition of the absolute value? Any expression in absolute value has two options. The positive of the expression if what? Or the negative of the expression if what? See, that's how my markers are getting dry. Because I'm waiting for your answer. So I have to put the cap on. Because it takes a while. So remember, this is just we mimic the formal definition. X in absolute value, X if X is greater than or equal to 0, or negative X if X is less than 0. So all I want you to say is if the expression is greater than or equal to 0, or if the expression is less than 0. Remember, all these 5 are identical. All of them are identical, whatever you have. Whatever you have, those 5 pieces have to be identical. The only change is here. Okay, so therefore, I'm just going to mimic. I have t squared minus 2t minus 8 if t squared minus 2t minus 8 is greater than or equal to 0. Or negative t squared plus 2t plus 8 if t squared minus 2t minus 8 is less than 0. 1, 2, 3, 4, 5 identical pieces. Okay, so now at this stage I got rid of the absolute value, but I have a different challenge now. What is it? Solving this. How do I solve that? How do I solve the inequality t squared minus 2t minus 8 greater than or equal to 0? To find a solution. Correct. But I'd rather factor because it's not difficult. But that's a very good point. Did you hear what Greg said? He said, should we use the quadratic formula? The answer is yes, if the solutions are not natural numbers or integers. Yes, I have to. I have no choice. But in this case, it's easy to factor. But if it's not easy to factor or it's not factorable, then I have to use the quadratic formula to find the solutions. Where, in other words, where it is 0. So how will I factor this? Luckily, yes, t minus 4 and t plus 2. And remember, we have to study the sign. And I showed you a little table. You don't have to use it if you don't like it. If you know a different method, that's fine. So in which you study the sign of the first factor, the sign of the second factor, and the sign of the product. Which numbers go in the table? At the top, where the variable is. Negative 2 and 4. In the correct order. Please be careful. Indeed. Negative 2 and 4, 0, 0, 0, 0. Since you don't have to think, I want you to think, but you know what I mean. I'm just giving you a shortcut. Both factors are linear functions with a positive slope. I don't need to study the sign. I know it's negative to positive. So negative till 0, positive. Negative till 0, positive. And then I can study the sign of the product. Because I'm not interested in this, and I'm not interested in this. I'm interested in this. So I multiply two negatives. I multiply a positive and a negative and two positives. So I know the answer now. So I will write that the absolute value of t squared minus 2t minus 8 is t squared minus 2t minus 8 if, and you'll tell me what, or negative t squared plus 2t plus 8 if what? Please tell me what to write. Yes? Careful. Let's go back. This is this if this quantity is positive. Where is this quantity positive?
Negative.
Exactly. Here. Union.
There.
Yes. So I have to write negative infinity, negative 2 with a bracket, union bracket 4 to infinity. I refuse to solve the second one. You should always refuse to solve the second one. Why? Because what's not in here must be in here. I'm not going to start from scratch and solve the other one. If the first branch contains this, the second branch must contain what?
Negative 2 to 4.
Right, with a parenthesis. No question about it. This was just a preliminary work to find the integral. We haven't even started the integral. But now we are ready. So we want to find the total distance as the integral from 1 through 6 from the absolute value of t squared minus 2t minus 8 dt. And it's obviously, since the function is a piecewise defined function, it cannot be just 1. Unless 1 through 6 is only found in one of the two. If 1 through 6 is only at the top, I don't need the second integral. If 1 through 6 is only here, I don't need the first integral. But if a piece of it is in the top and another is the second half, or the second piece is in the second one, then I need the sum of two integrals. Can anyone dictate the first integral? Of course. 1 to 4 and from 4 to, that's it. We have no choice. So then 1 through 4 and 4 to 6. But now we have to be very careful because we need to choose the correct function. Which function I have in here from 1 to 4? The first one or the second one?
Second.
Of course, the negative t squared plus 2t plus 8. And of course, the top one, t squared minus 2t minus 8 will be the second. It was a lot of work to come up with this, right? And now, from this point on, it's a piece of cake. So let's determine. Till we find the antiderivative, and then plugging in those numbers again is not an easy task. So negative t cubed over 3 plus 2t squared over 2, let's say t squared and 8t from 1 through 4, and t squared over 3 plus t squared, no, I'm sorry, it's negative, from 4 to 6. I looked at this by mistake, sorry. So t cubed over 3, that's correct, but then minus and minus. Okay, now the hassle starts. I don't like this part, but we have no choice. 64 divided by 3 plus 16 plus 32 minus, careful when we plug in 1, negative 1/3 plus 1 plus 8, plus, I plug in 6 now. 36 divided by 3, I think it's 12, minus 36 minus 48, and minus when I plug in 4, 16 over 3 minus 16 minus 32. Okay, let me check my numbers just in case. So 64 over 3, that's correct. 16, 32, that's correct. Minus 1/3, yes. 1 and 8, yes. Then 6. 36 divided by 3 is 12. Minus 36 minus 40, yes. Plug in 4. 16 over 3 minus 16 minus 32. Okay. Messy. But we want to find the total distance. So, okay.
So where did
Yes?
you get the plus 12, like the last row, like the plus 12 minus 36 minus 36?
So we have two integrals.
Right.
When I plug in 4, that's okay. When I plug in 4, I get this. When I plug in 1, I get this. But now when I plug in 6 in here, I get this. And then minus when I plug in 4, I get that. I have 4 pieces. Is this okay?
Yep.
I know it's messy. Okay, let's see what we get. Watch my numbers. Okay, negative 64/3 plus, I got 48 plus 1/3. This is 9 minus 9. Don't torture me if you have this number. Plus 12 minus, again I have 84. And then minus 16/3. And this is 48, but plus 48. See? Okay, let me check again. That's okay, that's okay, that's okay, that's okay, that's okay, minus, it's okay. See, I changed it, it was minus. And then positive 48, that's correct. Okay, now, let's see. So 60, 70, 80, minus 79 over 3. Correct me, please. So I get 70, 80. 80, negative 80 plus 1. I got that. Okay. So these are accounted for. Let's see what I have here. 48 and 48 is 96. And plus 12 is 108. So these are accounted for. And then I have to subtract 93. Am I correct? I got 15. Can anyone confirm any of these numbers? Negative 79 plus 45 divided by 3. I cannot get a negative number. So let's go back for a second. It's impossible to get a negative number. Why? I don't even need to look at the numbers. This is a positive function. the answer must be positive. There is no discussion. So if it happens that I get a negative number, I'll say no, 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 no. I have to go back to the drawing board. So, sorry, please go back and correct, please, please. I wrote squared instead of cubed, so that's why my whole thing collapses. I was getting a negative number, and that's not possible. Impossible. It's a total distance. It has the absolute value in it. So the fact that I put squared by mistake up there, I said unacceptable. So I went back and I realized that I wrote by mistake 2 instead of 3. So careful, I have to correct this big time. So this is again, that's 72, right? Okay. This is 36, that's correct. And this is 48, that's correct. But now this one is not. So this is 64. And that's correct. Okay, these two had to be adjusted. Okay, now, so this whole thing collapses. So I have to rewrite negative 64 over 3. That was correct. The 48 is correct. The 130 is correct. The negative 9 is correct. Now this is not. This is not correct. So this was negative 84 indeed, and plus 72 is minus 12. And now minus 64 divided by 3, and that is correct, but plus 48. Okay. So 64, and that's 128. So negative 128, negative 127 divided by 3. Okay, the 48 plus 48 is still 96. And I have to subtract 21. So I get 75. So negative 127 plus 75 times 3 divided by 3. And this must be a positive number. If not, you can throw me out the window. So 75 times 3. 98 over 3. It must be. This is one of the properties of the definite integral. The integral from a to b from a positive function has to be positive. And that tiny error that I made, my apologies, my mistake, no excuse, collapsed, and I said, oh, no, 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 no. It cannot be a negative number.
So the total distance has to be a positive number.
Because of the absolute value.
Absolute value.
Yes. So let's write this one more time. So, one more time. Don't want to forget this. If f of x is greater than or equal to 0, the integral from a to b from f of x dx must be greater than or equal to 0. Mandatory. So the integral from a positive function